Okay, we started with the question of sketch the fundamental triangle for the points 3, -2, and xy. Well, the fundamental triangles having been mastered a month ago, and they need to have been mastered a month ago, this should take only seconds. So we sketch the fundamental triangle, we label 2 points. Doesn't matter how we sketch it, the slope could be negative, it could be positive, makes no difference. This is a representative fundamental triangle, okay? So, just for something to look at, if this is 3, -2, and this is xy, then the rise is y minus -2, and the run is x minus 3 for reasons that we need to understand as completely as possible. So that the slope is y plus 2 over x minus 3. Now, this should be automatic. As soon as we see the coordinates of the 2 points, we should be able to draw the triangle, label the rise, label the run, and then write down the slope. Then the condition is slope equals 2. Okay, well, if the slope is 2, and if this is the slope, then this should equal 2. And that's what we write down, this quantity equal to 2. If the slope is equal to this, and the slope is equal to this, then this is equal to this. That's an equation in x and y, variables x and y. So we solve this equation for y. Now, in solving this equation for y, we multiply both sides by the same quantity. That's one of the rules. And the quantity that we multiply both sides by is, of course, this denominator. So that when we multiply both sides by x minus 3, as we've done here, x minus 3 in front of this quantity, and then x minus 3 in front of this quantity, both sides multiplied by x minus 3. We can rearrange this side with x minus 3 over x minus 3, and then that's multiplied by y plus 2, and the other side we went ahead and used the distributive law. We got 2x minus 6, and then x minus 3 over x minus 3 is 1. That's why we multiplied both sides by x minus 3, and that the goal was to clear the denominator. So x minus 3 over x minus 3 is 1, and 1 times y plus 2 is just y plus 2. So we get y plus 2 equals 2x minus 6. And we've done this by using the rules of arithmetic. And cancellation is not one of the rules of arithmetic. I don't like to talk about cancellation. I'm sure I've said that elsewhere, simply because people do it wrong. And I can't find a way to get people to understand the rules of cancellation, so we revert back to the rules of algebra, one of which says that if you divide a quantity by itself, you get 1. Another says if you multiply 1 by something, you get that something. The identity property. Okay, then y plus 2 equals 2x minus 6. I didn't write down the specific step, but you should be able to do that. We subtract 2 from both sides. We end up with y equals 2x minus 8, and that's our solution. So we solved this equation for y. So now we have a function. If we give this a function label, y equals f of x equals 2x minus 8. This allows us to talk about things like f of 0 or f of 5 and so forth. It gives us a compact way of talking about substituting a number in here or solving an equation of some sort. Okay, and we use this notation. This then is a function, and this function describes a set of all points y which are equal to 2x minus 8 for some number x. Now if we plot all such points, all of these points lie at slope 2 from the point 3, -2. Okay? So if we go from 3, -2 to any of these points, because of the way we've solved this, we find that the point xy will satisfy this equation, and I kind of lost the train of my sentence there, but that all the points x, y that lie at slope 2 from the point 3, -2 will lie on this graph, and every point on this graph will lie at slope 2 relative to the point 3, negative 2. So the graph consists of all points x, y such that the slope from 3, negative 2 to x, y is 2. And these points form a straight line. Okay? The slope between any 2 points on this straight line is going to be 2. We can prove this, but we're just going to assert it right now because we don't want to overload you with abstractions. Okay? So this relationship, or this function, has a graph that describes all points that lie at slope 2 from the point 3, negative 2. And the slope between any 2 points on that line is 2. Therefore, the line is a straight line. This is a graph. This graph gives you a straight line. Now let's verify that this graph will contain the point 3, negative 2. How do we do that? Well, if x is 3 and y is negative 2, then we should be able to plug 3 for x and negative 2 in for y and get a true statement. So we do that. We plug in x equals negative 3 and y equals negative 2. What do we get? Negative 2. Y is negative 2, so we have negative 2 equals 2x. That's 2 times 3 minus 8. And 2 times 3 is 6. 6 minus 8 is negative 2. So we get negative 2 equals negative 2, meaning that x equals 3, y equals negative 2 does satisfy this equation. So this is a point on the graph of this function. Okay, now let's determine, well, next we're going to determine the x and y intercepts of the line that we get if we draw a line from 3, negative 2 with a slope of 2. I'll do that in the next segment.